Sorry about that. I think it is recording.
Thank you, Brian.
Yes, thank you. Sorry about that. Thank you, thank you. I said remind me, I forgot. Anyways, so if you take equation number 1 and 2, let's say 1 and 2, okay, and solve for what? T1 and T2, correct? So there, you know, use kind of like elimination, substitution, whatever it is that you have in mind, you get T1 is equal to 1 and T2 is equal to 1 as well. Okay, so now substitute what? T1 equals 1 and T2 equals 1 as well in equation number 3 to see if it makes sense. Just because you intersected the first two lines, that doesn't mean it satisfies the third equation. In other words, this solution belongs to what? Pairing up equation number 1 with 2. But what about 3? Do these answers check this equation as well? Well, I think so, because if you replace this guy with 1 and that guy with 1, adds up to 4, so we are good to go. In other words, once you get your solution, make sure it satisfies the third equation. All right then, now you can go to either of these parametric equations, either go to equation number 1 and replace the T1 with 1, or go to equations, parametric equations number 2, replace the T2s with 1 as well, you get your common point. When you do, you get 3, 5, 1, and that's where these two lines intersect. Notice how I got these points. I went to either of these parametric equations, and I replaced the T1 with 1, and if you replace the T2 with 1, you get the same point. And this is called point of intersection. Do you see it? Point of intersection of those two lines. How could you tell if the lines are not parallel? Well, let's see now. We talked about this. What is the vector parallel to this vector, to this line? What is the direction of this line? It's 2, 2, negative 1. How did you know that? Those are the coefficients of the parameter. What is the direction of this line? Let's call this V1. Let's call this V2. That would be 1, negative 1, 3. I don't see that V1 is any scalar of V2. Therefore, what? They are parallel. Also, there was one other method to see if two vectors are parallel. If you take their cross product and the answer comes up to 0, then they are parallel. So there are two ways to check and see if two vectors are parallel to each other. Either one has to be a scalar, the other one, so k is a real number, right, scalar, or their cross product has to come up to 0. So this is two ways to check and see if they are parallel. In this case, when you do this, you are not going to get 0 vector, and V1 is not a scalar, what? Multiple of V2, so they are not parallel. So there are two possibilities left. Either they intersect, which we found out they do, or they are skew. How do you know they are skew? When you solve for equation 1 and 2 and substitute your what? Solution in equation 3, it won't satisfy it. Then you can tell, oh my goodness, they must be skewed lines. Do you see it? And later on, we can find the distance between two parallel lines, the distance between two skew lines, and those are, parallel lines are easy. Skew lines are a little bit challenging. It requires projection. But yeah, in a nutshell, this is what it is. But the last thing you want to do is use this kind of equation for what? Equation of a line in a space. It won't work. Why doesn't it work? Because on the floor, the line, what? Had a fixed slope. In a space is a vector. You can't use that. So therefore, please do not use this as an equation of a line in space, correct? Are we good? Is that okay with everyone? So that kind of takes us to a plane, correct? A plane. Turns out there are three ways you can write the equation of a plane. Is that right? So let me just walk you through these three possibilities. First of all, AX plus BY plus CZ is equal to D is called standard form of a what? Equation of a plane. As a matter of fact, this is called a linear equation in what? Three variables. Anytime you have a linear equation, whether it's two variables or three variables or one variable, you can bet your money the graph is a plane. It's not a line, it's not a point, it's a plane. Even though if two of these variables are missing, the graph is still a plane. We talked about that last time. However, keep in mind A, B, C, D are constants. So that's called standard form. So what are the possible ways of finding the equation of a plane? To find the equation of a plane, I need a point on the plane, like let's say x0, y0, z0. And also I need a vector which is called normal vector to a plane whose components are A, B, C. So one way to write the equation of a plane is what? Give me a point on the plane and give me a normal vector to a plane. What's the definition of a normal vector? Does anyone know? Which is denoted by lowercase n with an arrow on top. Does anyone know what is the characteristic of a normal vector?
It's perpendicular to all vectors on the plane.
Excellent. Every vector you what? You draw, every vector you draw, that guy is perpendicular to it. So that's the characteristic of a normal vector to a plane. So it's a vector perpendicular to every vector on the plane. So that's why it's called normal. Okay. Now, does it have to go upwards? Not really. It could also go downwards. Okay. As long as it is perpendicular to every vector on the plane, I'm good. Okay. Because what happens is if you take the what? The negative n, the signs will take care of themselves when you write the equation. You can just simply multiply both sides by negative and we're good. So it really doesn't matter at this point. So let me just put choose a what? A general point on the plane, call it x, y, z. And let me what? Kind of write this vector p1, p2 in vector notation. How do you write that in vector notation? That's like, you know, a directed line segment, and I'd like to write it in vector notation. If you remember, it's terminal minus initial, so this is x minus x0, y minus y0, z minus z0. You all see where that's coming from, right? So if this is my three-dimensional axis, and here is my vector with p1, p2, just draw the position vectors, like call this OP1, OP2, P1, P2, and notice OP1 plus P1, P2 equals OP2. Therefore, P1, P2 is equal to OP2 minus OP1, and that's why we're subtracting. So now, but remember, you just said what? Normal vector is a vector which is perpendicular to every vector you draw on the plane. Therefore, this guy, the dot product of this normal vector and this vector should be 0. So we're just going to go what? A, B, C dotted with x times x minus x0, y minus y0, z minus z0, so this should be equal to 0. If you take the dot product, you get a times x minus x0, b times y minus y0, c times z minus z0 equals 0. What is this equation called? What is the name of this format? It's called point normal form. So the point is inside the parentheses, x0, y0, z0. The coefficient of these parentheses happens to be what? The components of the normal vector. If you kind of clean this up and go like ax plus by plus cz equals ax0 plus by0 plus cz0, and call these guys d because they are all constants, then you get the standard form of the equation of a plane. So that's where this guy is coming from. Do you see it? So, question, give me a normal vector to a plane, give me a point, I can write the equation. Do you all see how the derivation goes? For instance, if I tell you the normal vector is 1, 2, 3, and the point on the plane is -1, 0, 5, how would you write the equation of a plane? You would always use the what? Point normal form. Guess what? This is your ABC, this is your x0, y0, z0. Use this form and then clean it up, put it in a standard form. In other words, go like this. 1 times x plus 1, because that's x minus 1, plus 2 times y minus 0, plus 3 times z minus 5 equals 0. So use the point normal form to write the equation of a plane, then clean it up so you can put it in a standard form, meaning remove the parentheses, keep the x's and y's on one side, the number on the other side, and we should be good to go. So x plus 2y plus 3z equals -1 plus 15, which is 14. There you go. Can I also direct your attention, ladies and gentlemen, that what? The coefficient of x and y and z happens to be what? The components of the normal vector. So pay attention to the coefficients of x and y and z, because they happen to be the coefficient of the normal vector to the plane. So why do I care? Well, suppose, let me get back to this in one sec. I'm just going to do a detour here. Suppose I give you 3x minus y plus z is equal to, say, 0. You should be able, or I should be able to tell just by inspection, what is the normal vector to this plane? What is it? Well, it's the coefficient of x and y and z, which is 3, -1, and 1. And the fact you have a 0 here, that just tells you the plane, what? Goes through the origin. Okay? So by inspection, I can tell if what? I can tell what the normal vector is. So the question is, why do I care? Well, if I give you 3x minus y plus z is equal to 0, and then I give you, let's say, I don't know, 6x minus 2y, let's say, plus 2z is equal to 1. So let's say this is the general equation of plane number 1. This is the standard equation of plane number 2. So the legit question would be, are these two planes parallel to each other? Well, I don't know. Two planes are said to be parallel if what? Can you guess? When do we say, what do you think? Two planes are said to be parallel if what?
Is it when their normal lines are
Vectors.
parallel? Or sorry, vectors, yeah.
Vectors. When the normal vectors, excellent, thank you, sir. Normal vectors are parallel to each other. So how would I know that? Is there anything I should solve for? Not really, because I can tell by inspection normal vector for first plane is 3, -1, 1. The normal vector for the second plane is 6, -2, what? 2. And now remember, there are two ways to see if two vectors are parallel. Either one is scalar multiple of the other one, or you take the cross product and see if you get a 0. Looks to me n2 is twice of n1, so therefore these what? Planes are parallel planes. You see it. Just like when you had two parallel lines, you compare their directions. Here, for planes, you compare what? Their normal vectors and see if they are scalar multiple of each other. So that way you can tell two planes are what? Are parallel. Let me see, cross product is 0. It's not 0, it's a 0 vector. So be careful, it's 0 vector, not 0. The dot product can be a number, but the cross product cannot be a number. It has to be a vector. So when I say 0, like in this content, I mean 0, 0, 0. Be careful, it's not 0 the number, it's 0 the vector. Do you see it? Incidentally, 0 vector is parallel to what? Every vector. Do you see it? So that's one case, right? That's one of the reasons I need to know by inspection what the normal vector to a plane is. The other way to find the equation of a plane besides given a point on the plane and a normal vector is if they give you two non-parallel vectors on the plane, like so. Okay. Suppose I give you two non-parallel vectors on the plane and I give you a point. Okay, let's say x0, y0, z0. Okay, and these guys are non-parallel, so V1 is not a scalar multiple of V2. So how would you write the equation of plane in this scenario? Any idea, guys? I can't hear you. Let's see, anyone have the answer? I recommend checking if both vectors are parallel to the scalar.
Get the cross product of both vectors and try to find the normal.
Excellent. We just went over this and the definition is still on the screen. Normal vector is a vector which is perpendicular to every vector on the plane. In this case, to find a normal vector, as the gentleman mentioned, what we do, we take cross product of these guys. In other words, let me just not do it, but give you the idea here. So to find a normal vector, because these are not parallel, take the cross product so you can get your ABC. Once you get your ABC, use the point normal form because you got the point, and finish the problem up. Remember, you also have the point. This is also given on the plane. Incidentally, speaking of a point on the plane, how would you know, let's say, where did I put it? Let me get back to this in one sec. Let me just ask you, where did I put the equation of a plane? Oh, right here. Can you guys tell me if this, let's say, point 3, -4, 1, is it on this plane or not? How could you tell? How could you tell if a point is on a plane, on the plane?
Do you plug in the x, y, and z values, and then they should equal 0?
Excellent, excellent. So to pick a point on the plane, you need to what? Let's say if I give you a point, as you said it correctly, so this should be like what? 3 times 3 minus 4 plus 1, that ain't gonna add up to 0. This point is not on the on the plane. However, a point like, let's say perhaps 1, what should I make this? -2, would that do it? -4, 1, would that be on the plane? 1, -4, 1, I don't know, 3, no, positive 4. 3 minus 4 plus 1 equals 0. Yes, it is. Now, here's my question to you. Remember in previous example, we found out the equation of the plane is x plus 2y plus 3z is equal to 14. Could you give me, out of millions of points on this plane, 1 point on this plane? Ready? Go. Give me a point which happens to be on this plane. Any point. Remember, you have infinite many options. But they can't be random. Just give me a random point. Okay, what would be
1400?
Sorry?
1400?
1400. Excellent. Excellent. Very good. How did she come up with? 14 plus 0 is 14. But that's one. Okay, give me one more just for laughs and giggles. Just one more.
911.
Sorry?
911.
911. So that would be 9 plus 2 plus 3, 14. Excellent. Can I give you guys one? Here's mine, which is, wait for it, 14 over 3. How's that? Will that do it?
Yes.
You want one more? How about, let's say, 070? There you go. That's how you pick a point on a plane. You see that? So, if two planes cross each other, okay, either two planes don't cross each other, they must be parallel, or they do cross each other, and if they do cross each other, guess what? They cross each other in a what? In a straight line. So the intersection of two planes is a line. Do you see it? Okay. So, how does plane, related, I mean, is there a connection between the direction of a plane and direction of a line? Check this out. Suppose you have a line, L, and the direction of the line is A1, B1, C1. And imagine you have a plane and the normal vector is A2, B2, C2. Here's the question. How would I know, case one, if a line is parallel to a plane? How would I know that? What should I check and see? Let's say you give me the parametric equation of the line, and let's say you gave me the equation of a plane. What should I check to see if what? Line is parallel to the plane. What should I check? I don't have a picture. I just drew it so you guys can see what I'm talking about. I will be given the parametric equation of line and the what? Equation of a plane. How would I know the line is parallel to plane?
If it's perpendicular to the normal vector of the plane.
Very nice. Excellent. 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 Here is the normal vector. Here is the direction of the line. They have to be perpendicular. In other words, to check and see if the line is parallel to the plane, take the dot product and see if it comes up to 0. If it does, the line is parallel to the plane. Excellent, excellent. Number 2, how would I know the line is what? Perpendicular to a plane. So here is the line, here is the plane. What should I check to see if the line is perpendicular to the plane? What should I check?
The vector has to be parallel to the normal.
Exactly. Thank you. Thank you. You guys are champions. Yes. Check and see if what? V1 is what? Is scalar multiple of n, because what? V has to be parallel to N when the line is perpendicular to what? To the plane. So with that in mind, so keep these ideas in mind because they show up in what? In a problem. So before I move the page, the line is said to be parallel to the plane if the direction of the line is perpendicular to the normal. So take the dot product and see if it's zero. You know what I'm talking about, right? The parametric equation will be given to you like so. Okay, there you go. Okay, t goes from negative infinity to infinity. Remember, if this is a line segment, then t goes from what? 0 to 1. Be careful. And what? Let's say this is O, A1, B1, C1. And let's say I get A2x to x, B to y, C to z is equal to, let's say, I don't know, D. So your direction is A1, B1, C1. Your normal vector is A2, B2, C2. Take the dot product, see if it's zero. If it is, the line is parallel to the plane. On the other hand, compare this vector, A1, B1, C1 to A2, B2, C2. See if it's a scalar multiple of one another. Then the line is perpendicular to the plane. With that said, so let's do this problem and take a quick break, guys. Find the equation, the parametric equation of a line, okay, through this point, which is perpendicular to this plane. So we are trying to write the equation of a line, specifically parametric equation of a line. Remember, t is the parameter. And in physics classes, t represents time, and what? Parametric equation represents the position of a moving object on the line. In chapter 13, we'll see what happens if the object is on any random curve, not necessarily a line. So we will examine that in chapter 13. So, any idea? Remember, the parametric equation goes like this. So there you go. Y0 bt, Z0 ct, and don't forget to tell people t goes from negative infinity to infinity. Because the minute you restrict this between 0 and 1, and inclusively, that means including 0 and 1, this guy becomes line segment. Okay, so what should I do? Yes. Where do I begin? I need a point, which I do have the point, there it is. But I need the direction of the line, which direction the line is pointing. Where would I get that direction from, folks?
Well, let's see. If the line's perpendicular than the plane, then that means...
So what does that mean?
That means the vectors have to be parallel, right?
Exactly. Exactly. There it is. There it is. The line is perpendicular to the plane, so the vectors have to be parallel. What does that mean? That means by inspection, just by looking at the standard form, find out what the normal vector is, which happens to be the coefficients of x and y and z, once you put the equation in a standard form. In this case, it's 1, 2, 2. So now, give me a vector which is parallel to 1, 2, 2. Ready? Go. Give me a vector which is parallel to this vector.
2, 4, 4.
2, 4, 4. Or, wait for it. How about 1, 2, 2? Would that work? Why? Because you're saying V is 1 times N. That would work too. So in other words, you decide that k is equal to 1. Usually people just take k equal to 1 and they get this the problem over with. So there it is. You got your ABC. You got your point. What are we waiting for? X is equal to 0, -7, what? 0. ABC is 1t, 2t, 2t. Excuse me. And t goes from -infinity to infinity. Ladies and gentlemen, this is the final answer. Right there. Equation of a line, which what? Which is perpendicular to what? To this plane. So there you have it. So is there any questions so far about plane? So let's take 5 minutes break or so. When we come back, we'll do some distance problems, and then we'll hit 12.6, do some graphs, draw some pictures. Any questions so far that you can think of? We good? Yeah, let's take a recess, 5-10 minutes, have a cup of coffee and come back so we can continue. Take care. I'll see you in a minute. So let me just stop recording. Thank you. 4y plus 8z is equal to 17. So you see what's going on here, right? We like to write the equation of this plane, correct? Which contains this line with this parametric equation, and it's parallel to this plane, and we know the equation of the plane. Any idea? Yeah, anyone? Let's see, if the planes are parallel, then their normals must be parallel. Excellent. So let's call this plane number 1, plane number 2. So we do know the normal vector to what? Plane number 2 by inspection is 2, 4, 8. Just like you said in the chat, then what? The normal vector, okay, to this unknown plane which we're trying to write the equation for is also 2, 4, 8, or any scalar multiple of it. As I said, just take the same thing, as if like k was equal to 1. Okay. But that doesn't quite solve the problem now. What else should I do? Any idea? Let's see if the planes are, yes, I got that. So yes, yes, we got that established. What's the next step? Okay. You can unmute yourselves, you know. Take a cross product of n and the line. Nope, I can't. I can't take the cross product of this line and the normal because I don't have a point on the line, on the plane. I need to select a point on the plane, and remember the way we come up with what? With equation of a plane, I gotta have a what? The normal vector and a point on the plane, correct? So yes, we know N1 has to be parallel to N2. I got that. But now, I need a point on the plane. Where is that point at? And how would I get my hands on? Sorry?
You could take a point from the line.
I can take a point on the line, correct? Give me a point on the line, please. Let me call this point Q. Give me a point on the line. Here's the parametric equation of the line. Go. Remember, t goes from negative infinity.
308.
Sorry?
308.
308. How did you come up with that? You set what?
T equals 0.
Equal to 0. You could have set t equal to 19 and come up with a what? With a point on the line. Okay. Now I need what? A general point on the plane. So I'm going to call that x, y, z. Okay. Then I'm going to what? Form this vector, so-called QP, which is x minus 3, y minus 0, z minus 8. Okay. So you see where we're going, right? They didn't tell me what the point on the plane is, so I chose a general point, x, y, z, and I formed this vector. So now, remember the line is not perpendicular to the normal vector. It's just a random line. How do you know this is perpendicular? I don't know that, right? I have no idea knowing what if this line is perpendicular to the normal vector because I don't so even if it is it what is the vector parallel to the line? Direction 2, 1, negative 1. Okay, let's take n1 dotted with v. Just for laughs and giggles, what is n? 2, 4, 8 dotted with 2, 1, negative 1. That's 4 plus 4 minus 8, which is correct. Right. But remember, the equation of the plane should have x and y and z in it. So that only solves what? If I take the dot product, so that shows you what? The line, the direction of the line is perpendicular to the normal because any vector you draw on the plane is normal vector is perpendicular to it. But the question is, you haven't given me a point yet. So what you do, you choose a general point, form this vector, and now what? Now you go, normal vector has to be perpendicular to any vector besides the direction of the what? Line. Also to this random vector which I just drew, you know, based on a point on the line and a point on the plane, correct? So what I do know that these are perpendicular, so I'm going to take what? X minus 3, y minus 0, z minus 8, dotted with what? 2, 4, 8, and set it equal to 0. Okay. Remember, selecting a point on the what? Line does not necessarily enables you to find the equation of a plane. You got to have a general point on the plane as well. Otherwise, you will have just nothing but numbers. So if you take the dot product, you get 2 times x minus 3 plus what? 4 times y minus 0 plus 8 times z minus 8 equals 0. There it is. There goes the equation of a plane. Do you see it? Let me see if there is any comment. Isn't the normal vector supposed to be perpendicular to all the lines on the, not lines, but vectors? Specifically what? The direction of the line, which it is. There, yeah. We already established that. So that has been established. There it is. But the question is, I was going to write the equation of this plane. So, let me ask you something. If I would what? Clean this up, I would get 2x plus 4y plus what? 8z.
Professor, the screen is frozen.
Oh my goodness. The screen is frozen. Oh my goodness.
We can't see what you're.
Oh, you cannot see the screen?
No, we can't see what you're writing. All it's like the original problem with the original diagrams.
Oh my goodness, I am so sorry, guys. Can you see it now? Let me see. What do you guys? Perpendicular. No, the share screen. Not the share screen. Oh wow. Let me share one more.
Never
time.
mind. I think it was a problem on my end. Thank you.
Oh, was
Sorry.
it? Oh, okay. No problem. No. Can you see it now?
Yes.
All right. Very
Thank you.
good. No problem. No problem. No problem. So you got, I think if I'm not mistaken, this would be like add up to 70, I think, because that would be like 6 minus 4 plus 64, which is what? 68? No, that's not it. 60. Is that right? Is that 60 or 70? So that's -6, that's positive, -4, and 64. Correct. So 68, so it's 64. Is that right? 60, what did I say? 266. Is that right, guys? So 266. So question, is this point on this plane 308? Let's see. 2 times, what was it? 3 plus 0 plus 8 times 8. That's 6 plus 64, which is 70. Is that 70? Or what is this?
Yeah, I think that should be equal to 70.
270. Okay. So, so yes, that point is on the plane. In other words, if you decided to use this point, you have the normal, correct? You have the normal. Then you can use point to slope form, which is a times x minus x0, b times y minus y0, c times z minus z0. I think that should do the job as well. But I went the other way. I decided to choose a general point, make a vector, and then take the cross product. I came up with this equation. And turns out that point, the line is on the plane, so any point on the line also should be on the plane as well, correct? So there you have it, and this is how you find the equation of a plane which contains this line and it's parallel to a what? Different plane. So with that said, let's do a couple of distance problems and then we should be good for this section. Sometimes the question is, you have a plane. Okay, can you see the screen, guys? And the equation of this plane is 3x plus 6y minus 2z is equal to 5. So this is the equation of this plane, correct? I have a point not on the plane, somewhere out there in space, like 0, 1, 5. How would you find the distance between the point and a plane? So the question is, find the distance between, what was it? P, the point, and the plane. May I remind you what we mean by distance? Does anyone know what are we referring to when we say distance? Let me see what I have on the chat.
Shortest distance
It's 70. Yeah, you're right. It's 70. Thank you, Nick. Appreciate it. What do we mean by distance? Yes. What kind of a distance are we talking about? Is this what we're talking about right here? Let me see, what do we have on the chat? The shortest possible distance, very nice. The shortest possible distance has to be perpendicular. This is what you want, not this. So when we talk about distance between two lines and a point and two planes, parallel planes, or a point and a plane, two parallel planes are coming up next. We're talking about the shortest distance, which is the distance perpendicular to what? To the plane. All right, so now, so we established that guy. So we don't need this. That's not the distance we are talking about. So any suggestions how to find this distance? Remember, it's shortest distance, which should be always normal. Of course, it's always perpendicular, right? Perpendicular is the shortest distance. So where do I begin? I got the point. I got the equation of a plane. I need to know the shortest distance between point and a plane. Where do I begin? Don't be shy. Shout it out. Let me know what you're thinking.
You choose a point on the plane and then create a vector.
On the
and then
plane.
scalar project that onto the normal.
Excellent. Give me a point on the plane, will you?
3, 6, 2.
3, 6, 2. Would that add up to 5? 9. What did you say? 3, 6, 2. 30.
Or I guess, sorry, 1, 1, 1.
1, 1, 1. That doesn't add up to 5, does it? Does it?
Must not be a good common sense day for me. My bad.
How about 5/3, 0, 0?
Hey, don't worry about it. Don't worry about it. You are good. Hey, how about put two of these guys equal to 0. You don't have to guess a perfect point. Put two of these guys equal to 0, like say y and z, solve for x. So that would be like, you ready? It would be like 5/3, 0, 0. There you go. That's a point on the plane. Okay, you don't have to give the perfect point. You know, replace two of these variables with 0 and solve for the third one, and there you have it. If you stick 5/3 here, you get 5, provided y and z is 0. Okay, good. Form this vector. Okay. So let's call that point vector PQ. Okay. You and I, we both know here is the normal. There. Do I know the components of the normal? I sure do. Those are the coefficients of x and y and z, provided the equation of a plane is in a standard form. So what I'm saying is, by inspection, you know the normal vector is 3, 6, -2. Good. So, as the gentleman said, I need this distance. This distance. This is the shortest distance. Do you see it? Which is the same as this guy. So that's the reason, one of the reasons why we learn projection. So I'm going to take the scalar projection of what? Of PQ, okay, onto N, which happens to be 3, 6, -2. Incidentally, you can also write this down, scalar projection of PQ onto N. There you go. Well, I'd like to develop the formulas. Let's say I forgot the formula. No problemo. This is what? Theta. Correct? You need this. So that has to do with cosine because it's adjacent side. So looks to me, what you need is what? Is hypotenuse, because this is a right triangle, magnitude of the hypotenuse, which is magnitude of QP, times cosine of theta. That will give you D, but mayday, I don't know theta. So somehow I gotta what? Convert this to dot product. How? By the way, why not cross product? Cross product has what? Sine in it. Dot product has cosine in it. Okay, so what do? Give a denominator of 1 to it. Multiply top and bottom by magnitude of n. Okay. There is no rule against that, right? Whatever you multiply top and you multiply bottom by, the fraction stays intact. Well, why'd you do that for? Well, if you recall, right, when I have magnitude of n times magnitude of PQ times the cosine of the angle between these guys, that's exactly the definition of n dotted with PQ. You see it? And because this is distance we're talking about, and what? Dot product can be negative, so I'm going to take its absolute value. Do you see it? And what do I get at the bottom? Magnitude of n. Okay. This should solve the problem. What is PQ? PQ is what? Terminal minus initial, right? Depending which way you go. Let's go this way. Let's go QP, for instance. So if you don't mind, let me just go QP. So what would it be? Terminal minus initial, that means 0 minus what? 5/3, 1 minus 0, 5 minus 0. There goes, PQ. Take this guy and cross product it, take the dot product with normal vector, but take its absolute value. In other words, go like negative 5/3, 1, 5, dotted with 3, 6, negative 2. That would be like the dot product. What is it equal to? Negative 5 plus 6 minus 10, which is negative 9, is it? You see why we have to take the absolute value? You cannot have a distance equal to what? Negative. What is magnitude of n? Is square root of 3 squared, 6 squared, negative 2 squared. So what's the final answer, you ask? It is 9 over square root of 9 plus 36 plus 4, which is 9 over square root of 49, which is 9 over 7. Final answer. You all see it? Yeah? That's the procedure to find the distance, the shortest distance between a point and a what? And a plane. You all see it? Do you see the screen? How it's done? Okay. I'm not gonna do the next one, but I'd like you guys help me out. Tell me what would be the procedure. What is the problem? Did you all get this? The problem is, what if the question was find the shortest distance between two parallel planes? So let's say this is plane number 1. This is plane number 2. This guy is x plus y plus z is equal to 1. This guy is x plus y plus z is equal to negative 1. And we need what? The distance between, what was it? Two parallel planes. Remember, we're talking about shortest distance. Okay? So give me an idea where to begin so I can kind of see if you're on the right track. First of all, how do I know these planes are parallel? I know I was told they're parallel, but how would I check mathematically to see if they are parallel. Yes,
Inspect and see if their n vectors are parallel.
correct. Inspect the normals. This is 1, 1, 1, so is this guy. In other words, they are scalar multiple of each other. This guy is 1 times this guy, so they are parallel, so we are good. Okay, so we got that. Now, how would I find the shortest distance between these two planes? So, okay, we checked that they are indeed parallel. Okay, now what?
A line that is normal to both planes would be the shortest distance.
The line which is normal to both planes. Well, you mean the vector, right?
Yes, I'm sorry. I mean the vector.
Okay. But how would I get my hands on that vector, mysterious vector? How would I get my hands on it? Keep in mind what? These guys have the same normals. So in other words, let's say,
I have an idea.
yeah, let's hear it, please.
Okay. Find 1 point on P1 and find a point on P2.
Okay.
And then,
yeah.
Yeah.
Go ahead.
So, and then you have to connect the two and create a vector from those 2 points.
Okay, gotcha. I'm with you so far. Keep going.
Well, that's what I have at this moment.
Okay, and that's a fantastic start. Very good. I mean, this is excellent. I mean, I'm so glad you have that much.
Can I
So,
add on to what he was
we
saying?
have part 2. Yeah, did you hear what the gentleman said? He said, pick a point here, Q1, pick a point here, Q2, form this vector, and now I'm waiting for part 2. Then what do I do?
Do we basically just do what we did in the example before this?
Exactly, we do what we did previously. In other words, they both have the same normals. So the normal of this guy is the same as normal of that guy. Okay, same normal, because they're parallel. So now, scalar projection, there goes the distance. But could you give me a point on plane number 2? Remember, I showed you how to pick a point on a plane. Ready?
-1, 0, 0.
Ah, there you go. You got it. Here?
1, 0, 0.
1, 0, 0. Form this vector, and now you are back to previous example, which you know what we did. Take the scalar projection of this vector onto either of the normals, because they're parallel anyways. Who cares which normal you select? They will do the job. And this, folks, is the shortest distance between what? 2 parallel lines. Okay, to find the angle between what? 2 intersecting planes, you find the angle between their normals. And by definition, we always accept the acute angle, meaning the angle has to be somewhere between 0 and 90 degrees. So keep that in mind. So use the normals, use the dot product to find the angle between the vectors. Here they are parallel. There is no angle. Angle is 0. But if they would intersect each other, then what? Then you would find like so here. Okay. Notice they intersect each other at on a line, that the intersection of 2 planes. Okay. And what? We always get 2 answers. One is obtuse, one is acute. We always choose the acute. In other words, you need to use what? this formula, you know, the dot product, okay? Everything is known except theta. Solve the equation for what? Cosine, then take the inverse, and lo and behold, you get what? 2 answers. One of them happens to be like, in my example, 198. We don't accept that because by definition it's acute. And the other possibility is 79 degrees. And that falls into 0 and 90. So the acute angle between two intersecting planes is called the angle between two intersecting planes. And two planes intersect each other on a straight line. So that's pretty much all about planes. So is there any question before we move on and do a couple of graphs so we can continue this on, when was it? Thursday. So Thursday we'll kind of do more graphs and hit 13.1, which is parametric equation of any curve in the space, not just line, any curve. So that's what's coming up in 13.1, which talks about vector valued function. Those are the functions. Domain is all real numbers, but the range is vector. And we will see what those guys are all about. Okay, so there you go. So you guys remember conic sections in college algebra classes. So conic sections are cross-section of how you intersect a circular cone with a plane. Okay, if you cut it, the cross-section will have a variety of curves, such as an ellipse, such as a parabola. So ellipse is one of the cross-section, parabola is the other guy, circle is the other guy, and then we have something called hyperbola. Okay, equation of ellipse was x squared over a squared, y squared over b squared equals 1, where a was not equal to b. Parabola was what? Y equals what? You remember, what was it? Kx squared. Okay. If it goes up and down, it's kx squared. So these are like, you know, pictures. If it goes sideways, it will be x equals ky squared. But anyways, you know what the equation of a parabola is. Circle is a special case of an ellipse. Ellipse is the oval shape. So this is oval, this is parabola, and this guy is circle. In other words, still the same equation, except the denominators now are identical. So therefore, circle is a special case of what? An ellipse. Hyperbola looks like this. X squared over a squared minus y squared over b squared equals 1, or y squared over a squared minus x squared over b squared is equal to 1. Hyperbola is like two branches of parabola, which they go opposite sign. So in the first case, the branches open along the x-axis. In the second case, because y shows up first, the branches opens up along the y-axis. So guess what? In three-dimensional space, we have something called what? Quadric surfaces. Not quadratic, but quadric. Quadric means what? The degree of the x and y and z are 2. So this is a general equation of a quadric surface. Notice it's a very long equation. Starts with ax squared and ends with a k, where all of these letters happens to be constant. So, so cylinder is one of these, is a special case of what? Quadric surface, where you have x squared and z squared, and you have k. everything else is 0. So notice you have a what? A cylinder. But the graphs happens to be, if you have checked the videos, if you have watched, there are these 6 graphs. This is called ellipsoid, which looks like a football. And the equation of that guy is, notice, all the variables have powers of 2, and there are pluses between them, and there is a 1. So this is a standard form. If A is equal to B and equal to C, that means if the denominators, let me just zoom in, denominators match, then that would be a sphere. So a sphere is a special case of ellipsoid. Soid means like. So when you say ellipsoid, that means it's like an ellipse, but it's not a curve. In other words, what I did here, folks, right here, these are a bunch of curves. These are curves. But these guys are surfaces. They are not curves. They have, they are three-dimensional surfaces, okay? If you have one of the variables on one side, the other 2 on the other side, but still the powers are 2, and still there is a plus, the graph comes up as a cone. If one of the variables has power of 1, as you can tell, z has a power of 1, but the remaining variables have powers of 2, but you still have a plus, this is called elliptic paraboloid, meaning it looks like a parabola, but on top it looks like an ellipse. So, but it's not a curve, it's a surface, correct? However, if A is equal to B, then we call this circular paraboloid. If A is different than B, we call it elliptic. Now, if you have squares, but one of the variables have minus, this is called hyperboloid of one sheet, which looks like nuclear power plant. And the mathematical name is hyperboloid of one sheet. On the other hand, if you have the same equation, but you see 2 minuses with all the variables with the powers of 2, these are called hyperboloid of 2 sheets. And if you have, remember elliptic paraboloid, if you have the same scenario, but with a minus between x squared and y squared, or between any other 2 variables, and the other variable has a power of 1, this is called hyperbolic paraboloid, which the common name for it is called saddle, which looks like a saddle, doesn't it? Saddle, this point is called minimax. In other words, if you look at it from the top, is minimum. If you look at it from the bottom, is maximum. So sometimes saddle is called minimax point, this point right here. But mathematically, it's called hyperbolic paraboloid. So these are the 6 quadric surfaces, which we need to know how to graph these. Can I just graph one of these guys in 5 minutes, just one of them, so we can at least get an idea how would you start even graphing these guys? Although you can plot these on Cal Plot 3D app and go from there. But make sure you know how they look like, because we need these pictures for upcoming chapters. I gotta know how these guys look like so I can find the volume of these guys, so I can find the surface area of these guys. So please get yourself familiarized with these quadric surfaces, specifically these 3. This guy, elliptic paraboloid, ellipsoid, and cone. These guys hardly show up in upcoming chapters. Make sure you know these 3. Ellipsoid, elliptic paraboloid, and cone. All right. So what is this? This is the same as elliptic paraboloid. It's kind of like this, except ABC happens to be 1. So we call this circular paraboloid. Okay. So how do you graph this? You find the shadow of this. So that means project this. So projection of 1 onto XY plane. Then you find projection of 1 onto what? XZ plane. You know, these are this is the floor, this is the one of the walls, and this is the adjacent wall in a room onto YZ plane. Let's see how the shadow of these guys look like. When I say projection, that means when you shine a light from the top, how would that guy look like on the floor? Okay, so that would be like x squared plus y squared is equal to 0, which is a point. Okay, what about its shadow on one of the adjacent walls? Well, that would be the same as z is equal to y squared. Okay, do I have it? I meant to say x squared because y is 0. So on the xz plane, the graph is a parabola. Okay, and here you would have z is equal to y squared. So on the yz plane, the graph is still a parabola. You all see it. So these are the projections or the cross sections of what? Of this surface with, like in this case, with what? With z is equal to 0, with y is equal to 0, with x is equal to 0, which these guys happens to be a plane. Okay, they are not a point, they are not a line, they are plane. So the intersection of two surfaces is a curve. And that's what we got, a curve. Anyways, let's just wrap this up. Here is the axis. Okay. Here is one of the parabolas. Here is the other one. Okay. It really doesn't matter which is which. The idea is that you get two parabolas and a point. But just what happens up here. So let's say we set z equals 1. Let's see what happens to the surface at or on z is equal to 1, which is a plane. In other words, if this is the plane here, and let me just make sure you draw the plane, what would be the graph intersection of what? The plane equal to 1 and this surface? Well, that means you get this curve. What is that? That's kind of a circle. So what you do, you kind of draw a nice circle here. And ladies and gentlemen, that is called circular paraboloid. It's like a bowl which what can hold water. So that's how the graph looks like. If you don't want to graph this accurately, but at least know how the graph looks like, keep in mind if you had x equals what? Y squared plus z squared, then the elliptic paraboloid will open up along the x-axis and so on and so forth. Do you all see it? Does anyone know how the graph of this guy might look like? Minus x squared minus y squared?
Is it the same graph but facing downwards?
Exactly. It's upside down, like so. Can you now tell me how the graph of this guy looked like?
It's 1 unit upward shifted.
Shift this 1 unit up. Excellent. Why did I bring that up? In chapter, I believe 15, we will find the volume of these two elliptic paraboloids, you know, somewhere in between. You know, this guy goes like so, that guy goes like so. So we like to know the volume between these two elliptic paraboloids. And we will find those in chapter 15. So it would be nice to know which surface is on top, which surface is at the bottom, so I can accordingly set up the limits of integration. With that, guys, have a great night. Thank you for participating. I sure appreciate your feedback, and please keep in touch. Thank you, guys. Good night.